Hey everyone, and welcome to a brand new explainer. Today, we are going to unlock one of the biggest, most mind-boggling secrets of the entire universe. We're talking about the invisible cosmic glue that builds stars, holds galaxies together, and literally dictates how every single object moves. Now, I'll let you in on a little secret. We're diving into some real ninth grade level science today. But don't worry, we're going to break it down so simply and have so much fun doing it that anyone can completely master it. All right, let's dive right in.
So I want you to imagine something for a second. Imagine standing up from your chair right now and jumping as high as you possibly can. What happens? Well, you might get a second of airtime, but then, bam, you come right back down to the floor with a bump. You don't just keep floating up through the ceiling and into outer space, right? But why? Why doesn't a jump just send you soaring into the clouds?
The answer, of course, is gravity. You can think of gravity as this giant, totally invisible cosmic magnet. It's a natural force of attraction between literally all objects in the universe. Right now, as you're sitting there, it's the invisible force keeping your feet firmly glued to the ground and stopping our planet's atmosphere from just drifting away into the emptiness of space.
Now, let's play a little game to test how this invisible pull actually works. I want you to imagine holding a super heavy bowling ball in one hand and a really light little onion in the other. If you let go of both of them at the exact same time, which one falls faster and hits the ground first? You'd probably think the heavy bowling ball, right? I mean, that just makes sense. Even ancient philosophers like Aristotle thought heavy things fall faster. Well, a famous scientist named Galileo decided to test this hundreds of years ago. Legend has it he dropped different objects off the Leaning Tower of Pisa in Italy just to see what would happen. And get this, much later, in 1971, an astronaut named Dave Scott actually did a similar experiment while standing on the actual surface of the moon. He dropped a heavy hammer and a light feather at the exact same time. Now, get ready for the craziest part. They hit the ground at the exact same time. No way, right? Galileo proved it down here on Earth, and the astronaut proved it up on the moon, where there's no air to slow that feather down. Without air resistance getting in the way, a heavy bowling ball and a light onion fall at the exact same speed. But wait, how is that even possible? Doesn't the Earth pull harder on heavy things? Well, yes, it does. But here's the secret. Gravity is actually a little bit lazy. Gravity only puts in the exact amount of effort needed to move an object's mass, and not a single ounce more. Think about it like this. If you want to push a heavy car down the street, you need a huge amount of force. But if you want to push a skateboard, you only need a tiny little push. Gravity works the exact same way. It pulls incredibly hard on the heavy bowling ball just to get it moving, and it only pulls a tiny bit on the light onion. The pull perfectly balances out how heavy they are, which means they speed up and fall at the exact same rate. So what is that rate? If everything falls together, how fast are they going? The magic number here on Earth is 9.8 meters per second squared. That's our planet's official acceleration due to gravity. It basically means that for every single second an object is falling, it speeds up by 9.8 meters per second. This is what scientists call free fall, which is when gravity is the only force acting on you. Okay, let's see how this builds into an even bigger idea. Enter Sir Isaac Newton. Back in 1687, the story goes that Newton saw an apple fall from a tree. And it really got him thinking, why did it fall down? Why didn't it fall up or sideways? He realized that the exact same force pulling the apple down was the force keeping the moon up in the sky. He had just discovered the ultimate rule of the cosmos. Newton called it the universal law of gravitation. And hey, don't let those big words scare you, because the rule is surprisingly simple. It basically says that absolutely every object in the universe pulls on every other object. And the strength of that pull? It comes down to two things. First, big, massive objects pull harder than small ones. And second, things that are close together pull harder than things that are far apart. So here is the really mind-blowing part. Because everything pulls on everything, you are actually pulling on the Earth right this very second. You literally have your own gravity. But because the Earth's mass is so unimaginably gigantic compared to yours, the Earth easily wins the tug of war. That's why you fall toward the Earth and the Earth doesn't visibly jump up to meet you. Now that we know about mass and gravity, we really need to clear up the biggest, most common mix-up in all of science history. We hear these two words all the time, mass and weight. When you step on a scale in the bathroom, are you measuring your mass or are you measuring your weight? Are they just the exact same thing?
Nope. They are totally, completely different concepts in physics. And honestly, knowing the difference is the absolute key to understanding how astronauts do such amazing things in space.
Let's break it down using a really fun analogy. Think of your body as a giant Lego model. Your mass is simply the total number of Lego bricks that you are made of. It's the total amount of matter inside you. Your weight, on the other hand, is a force. Weight is how hard gravity is pulling down on all those Lego bricks and squishing them onto a scale. So mass is the stuff, weight is the squish.
So here is a really cool fact. Your mass never changes. No matter where you travel in the entire universe, whether you're on the moon, on Mars, or just floating in deep space, you will always be made of the exact same number of Lego bricks. Your mass is a fundamental property of who you are. But your weight? Your weight changes completely depending on where you are. Let's take the moon, for example. The moon is much smaller than the Earth. Because it has less mass, Newton's law tells us it has a weaker gravitational pull. In fact, the moon's gravity is only about 1/6 as strong as Earth's.
This brilliantly explains why astronauts look so incredibly cool walking on the moon. When Neil Armstrong was bounding around on the lunar surface, his mass was exactly the same as it was on Earth. He still had all his Lego bricks. But because the moon's gravity was only pulling on him with 1/6 the strength, his weight dropped drastically. That's why he could bounce super high, even while wearing a massive, heavy spacesuit.
And if you were to travel into deep, deep space, like far away from any planets or stars, the gravitational pull on you would be almost zero. You'd be completely weightless. If you stood on a bathroom scale out there, it would literally read 0. But remember, your mass hasn't changed at all. You are still completely you. Okay, let's bring it back to Earth for our final, biggest mystery of the explainer. If Earth has so much mass and its gravity is constantly pulling on everything around it, why doesn't the moon just fall out of the sky and crash right into us? We know gravity works over long distances, so what on Earth is keeping it up there?
Are you ready for this? The moon isn't just floating peacefully up there. The moon is actually falling towards the Earth. Right now, at this very second. Earth's gravity is pulling the moon down, just like it pulls an apple from a tree. But here is the trick. The moon is also moving forward completely sideways at an incredibly fast speed. It's moving sideways so fast that as it falls downward, the round Earth actually curves away underneath it. It's constantly falling, but the ground keeps curving out of the way, causing it to constantly miss. And boom, that right there is the scientific definition of an orbit. When a planet, a moon, or even a satellite is in orbit, it is simply falling forever but moving horizontally so fast that it just keeps missing the ground, tracing a giant, continuous circle in space. It's truly amazing when you stop and think about it, isn't it? This one simple, invisible pull between objects is the master builder of the cosmos. The moon's gravity pulls on our oceans to create the daily tides. The sun's gravity keeps our entire solar system in perfect falling orbits, and supermassive black holes use gravity to hold entire galaxies containing billions of stars together. So, I'm going to leave you with this fun question to think about. If orbits are just about falling and moving sideways really, really fast, if you had a super-powered robotic arm and you threw a regular baseball horizontally fast enough, could that baseball enter orbit and eventually hit you in the back of the head? Well, the laws of physics say yes. Thank you so much for joining me on this explainer. Keep wondering, keep looking up, and never stop exploring the incredible forces that shape our universe.